The product rule allows us to take the derivative of two differentiable functions that are multiplied by each other. As a rule, it says that if you want to take the derivative of the product of two differentiable functions, you don't take the derivative of the functions and multiply by each other. Instead, you would use this formula that states you would take the derivative of each part and multiply it by the other function itself. So I would take a derivative of f prime of x and multiply it by g of x. And I take the derivative of g prime of x and multiply it by f of x. And then the results get added together. Here's the proof of why this works. We'll start with the derivatives definition. We set up a difference quotient for the product of f of x, g of x, and take the limit as h goes to 0. So first thing we're going to do is insert an extra term in this difference quotient. And you know, if you notice, we are subtracting and adding it so that these two terms would normally cancel, and the difference quotient's value has not changed. But these terms allow us to get where we need to go. So in this case, the terms that we start with is negative f of x g of x plus h. And again, then we add the same term, so the value of the expression has not changed. So what we'll do next is take this and group it and factor. So from the first two terms, we're going to factor g of x plus h because they have that in common. From the second two terms, we're going to factor f of x. And this is what we are going to end up with. G of x plus h times f of x plus h minus f of x. That's the result of the first two terms. And from the second two terms, we'll have f of x multiplied by g of x plus h minus g of x. Next, we'll split this into two fractions. They're differentiable, so I pass on the limit and break this up at the sum. I'll use the linearity of the limits. And then what we'll do is take the limit as h goes to 0 and apply that to the g of x plus h. F of x did not have an h in it, so I can just move that to the front. It's a constant as far as our limit's concerned, right? And g of x plus h as h goes to 0 turns into g of x. And the remaining parts, f of x plus h minus f of x over h, as the limit h goes to 0, is the derivative of f prime of x. That's the definition of the derivative. And this part is the definition of the derivative of a g of x. So what we are going to end up with is g of x f prime of x plus f of x g prime of x, which basically is what the product rule says. Maybe just different order, but it's the same formula. And now we can generalize this product rule to 3 or more functions. So here's the same rule when it's applied to 3 functions being multiplied. Again, as long as all 3 functions are differentiable, the way you would take the derivative is take the derivative of one part and multiply it by the other 2 functions. Not the derivative of the other 2 functions, but the functions themselves. And repeat that for each function. So g prime of x gets multiplied by f of x and h of x, and h prime of x gets multiplied by f of x and g of x, and then the results are all added. And if I had 4 functions or 5 functions, the process would still work the same. You take the derivative of one of those functions, multiplied by the remaining functions, add it to the derivative of the second part, multiplied by the other functions, and so on.